Hey there, ladies and gentlemen. I am Leonardo DiCaprio, Oscar winning star of movies such as Inception and, well, let's not talk about myself anymore because we are here to talk about your fantastic math teacher, Mr. Ng, today. And let me just tell you, he's something else, isn't he? So, yeah, here's what you're going to do today with Mr. Ng, okay? He's going to teach you how to complete the square when you factor trinomials. Okay, so this is very much the same. We're still factoring, but we're using a very unorthodox method. Okay, so listen to your very good math teacher, Mr. Ng. All right, and once again, this is Leonardo DiCaprio signing off here. Take care now. Well, thank you very much, Leo. It's always good when your good friends, lend a helping hand to help these young people. You guys learn how to complete the square and factor trinomials, things like that. Because Leo and I, we go way back, man. When we grew up in LA together, and we're family friends and all and whatnot. But anyways, let me not drop names anymore, and let's just focus on the task that's at hand. And so, okay, so here's what we're gonna do today. So today we're gonna talk about completing the square. Okay, it's another method to factor polynomials. Okay, I just want to get that through first. Now, before we do that, let's just see how we got there, how we got here, and where we're going next. Okay, just so that it gives you some perspective. So here, now the very first thing, and it's we've done some basic factoring of trinomials. Now, when I say basic, I don't really mean basic because we must have spent like at least over a week on this, right? And so when I mean basic, I mean like things that you can unfoil using the methods that I've shown you so far, where you get whole number answers. All right, so if you set this equal to 0, right, you would get x plus 2 equals 0, and then x plus 3 equals 0, and then you just solve for it, right? There you will get your zeros or roots, as we say, right? Now, what if, right, but because this is really the big question here, what if we can do it? So what if these numbers aren't whole numbers, and as a result, we cannot factor this? Now, I've said it once before in a video earlier that when we say we can factor, it really doesn't mean that there's no answer. There's always an answer. It's just that not all your answers are gonna be whole numbers, or your roots, or your solutions, or your zeros are gonna be whole numbers. So the question is kind of like, well, okay, what do we do then, right? Because this method's no good here, okay? All right, the light just went off. Come on. Now, that said, there are two methods usually we can go about solving that, all right? And neither one is elegant, but sometimes when you have to get down to the nitty gritty of decimals, right? Because think about it, if we cannot get whole number as an answer, what that's suggesting is our factors are gonna be decimals, right? And for us to get to that point, the solutions are a little bit less elegant than we would otherwise solve it with, okay? And there are two ways you can do that. The first way is what we're gonna do for the next few days. It's called completing the square, all right? And I'll get to it, in a moment, all right? And the second way of kind of going through it is by using the quadratic formula. And the reason why I have a sledgehammer here is because that's what the quadratic formula, just look at this, right? By the way, so you're gonna have to learn how to use that, all right? And we'll get to that probably in about a week. But the reason why I have a sledgehammer is because like if all else fails, so if we can't use basic factoring, right, old school style, and we can complete the square, what we're gonna learn this week, then the last resort is by using this very cumbersome, very, gigantic formula called a quadratic formula, all right? So I'll give you the analogy. It's like if you want to, how do I say it? All right, it's if you want to you know, what, if you're doing a construction at home and, you know, you want to put a nail on like the wall or something, okay? And you don't have your regular size hammer, right? You know, the sledgehammer is gonna have to do, all right? Without, you know, breaking the drywall. But, you know, but you guys understand my analogy, okay? It's a very blunt instrument, but guess what? You always get an answer, okay? So think of it like that. Now, so let's focus on what we're doing today, all right? Called completing the square. So I wanna show you, there are a couple of ways I can show you. So the first thing I want to do is by having you actually copy this equation. That's what I want you to do actually. All right, so copy this equation, all right, write the word completing the square on the top of your notebook. All right, so I'm gonna show it to you one way first by using perfectly regular trinomials, because I want to show you the technique first before we get into all the square roots and stuff. Remember, right? Because the only reason why we're really using completing the square, besides the fact that, you know, on the regions they make you do it, all right, is that we don't have whole number answers, solutions, okay? And that's why we have to resort to completing the square. So, but that also means that your answers are gonna have decimals, and I don't wanna get there yet. I want to show you the method first so that you guys get the method down without worrying about how to write the answers. And then once you get a grip of that, all right, then I can show you the answers where you got like, you know, square roots and decimals and all that, okay? So now, that said, all right, now here, right, I already know that based on what I just said, right, that you already know the answer. Let's just put it that way, right? Because this is x plus 2 and then x plus 4, right? And so the other way, right, so let me show you how to do this by completing the square. Now, here, you can see that, right? Here we have x squared plus 6x plus 8. Now, here's the thing. In order to have a perfect square, let's just say like, you know, we're all like perfectionists, right? And we say, you know what? I sort of wish that this was a 9, because if I do that, you know, like life would be so much easier, right? Well, a little bit easier, right? Because then I would have a perfect square, right? I could just do x plus 3 times x plus 3, because that would give me x squared plus 6x plus 9. And then, you know, not only that, I could write it even shorter, right? Because I could just write this square, right? Because these two things are one and the same things, right? So here's the question. How can we do that? And the first question is actually, is it possible? And the answer for that is yes. And the second follow-up question is, well, so, okay, how do you do that then, right? So let me show you. So this is how you complete the square, okay? Now, first of all, it's a little bit inconvenient that the plus 8 is on this side, because I want to make room and put 9 here, right? So the 8's got to go. So how do we just move the 8? Easy. We just move it to the other side. By doing what? Yeah, we subtract. So this is step 1, okay? So write down the question, by the way, all right? So I'm gonna just subtract 8 on both sides, all right? So let's take a look. So here I got x squared plus 6x. These cancels out, and now that's negative 8, all right? So far, so good. Now, here the problem then is I need this, all right? And I can't believe I just did this a second time. All right, so I need this right here. All right, I need this to be a 9, right? Because you would know that by putting a 9 here on the left side, I'm gonna have a perfect square, okay, right? Perfect square trinomial. Hold on, the computer's stuck. So in other words, right, again, right, I need to know what I can put in here so that I get a perfect square in the left. Now, you know and I know and everyone knows that this has to be a 9, all right? And I kept this simple. Now, here's what you can do though, because sometimes the numbers aren't that obvious, right? Between like, you know, 6x and 9, right? So I'm gonna draw a little box on the side and show you how to do this, all right? So now, here's what you do. Here's the trick, okay? Take the number in the middle, the 6, divided by 2, which would give us 3, right? And then you square that answer. All right, this works for every single one, even negative numbers, okay? Remember that, even negative numbers. Now, here I got positive 9, right? So let's see, what's the best way to do this, one step at a time. So here's what I'm gonna do, I'm gonna rewrite this. just to show you what's going on here. Now, here, I know that now I can put the 9 here, but here's the thing. Remember equations, right? The balance method. Whatever you do on the left side of the equal sign, you have to do the same thing on the right side. Okay, so far so good. Now, that would mean that, I'm going to rewrite this again, right? That now I got myself a perfect square trinomial on the left side, and here, negative 8 plus 9 is just positive 1. All right, so far so good, right? So our dream is kind of coming true, right? Hold on, the light just went off. Right, so you see that on the left side, right? Now we got a perfect square trinomial. Now, can we just rewrite that? Right, I do x and then that's plus 3, and that's plus 3, and that's equals 1, right? But at the same time, isn't there another way that we could write that? X plus 3 times x plus 3. What do you think is another way to write that using exponents? Yeah, right, x plus 3 squared, right? Nothing new here. So far so good, right? Now, here's the next step. Remember how to solve these sort of equations, right? That's why, again, we did that like, last week, right? So here I'm going to take the square root on both sides. Right, again, it's the balance method, right? So whatever we take the square root of on the left side, we have to do the same thing on the right. Now, let me rewrite this out here. Let's see. You know what? We don't have to. Okay, here I got x plus 3, right? Because the roof, right? The radical symbol is canceled out. Now, what's the square root of 1? Yeah, 1, right? Positive or negative 1. So now we got ourselves two equations. X plus 3 equals 1. X plus 3 equals negative 1. All right, and we're going to solve for it. Subtract 3 on both sides. X is equal to negative 2. Subtract 3 on both sides. X is equals negative 4. Oh, look, same answer as we had before, right? So there you go. And that's how you do that. And that's how you complete the square. Okay? So what I'm going to do is this, all right? Since I left all these steps here for you to follow, I would like you to try it with this example. Okay? So press pause right now. Press pause right now. After you're done, I'm going to come back and show you how, and go over that with you. Okay? So press pause right now. Okay, all right, here we go. Now, okay, so step 1, right? So step 1, I need to move this guy. Again, right, this is not a perfect square, but you already know. I mean, you should know what the answer is, right? I mean, because here we got n, right? To get negative 3, it'll be 3 and 1, and since the middle term is a negative, the bigger number has to be a negative, right? So that's our answer that we're going to be looking for, okay? So now, step 1, right? So we got to move this guy to this side because I want this expression on the left to be a perfect square, all right? So we want everything to be perfect. So I'm going to move it to the side. How do I do that? I just add 3 on both sides. Like that, right? So that would be n squared minus 2n equals to 3, right? So far so good. Now, what's step 2 then, right? I need to know what this here can be so so the whole expression on the left side is a perfect square trinomial, right? So I'm just going to take the negative 2, all right? And this is fine. We can use the negative, all right? Divided by 2, that's negative 1. Negative 1 squared is what? Yeah, right? Positive 1. So here I need to plus 1 here. Okay, so I'm going to add 1 here on the left side, add 1 on the right side. All right, so far so good, right? Because now we have a perfect square trinomial, right? So I'm going to rewrite that. All right, now 3 plus 1 is 4, all right? So let's see, that should be n. Now, how do we get this? Well, it's n minus 1 times n minus 1, right? That's how I get n squared minus 2n plus 1 on the left side. What's another way to write that? N minus 1 squared equals 4, right? Next step, I'm going to bring that down just so that I can take the square root of both sides, right? Square root, and then I'm just left with n minus 1 on the left side and then plus or minus 2, and now I solve the equation. So n minus 1 equals 2, n minus 1 equals negative 2, plus 1, plus 1, n equals 3, plus 1, plus 1, n equals negative 1. And wasn't that the answer, right? Because this is n equals 3, and this is n equals negative 1, right? After you set it to 0. So there you go. Okay, that's how you do that. Now, let me kind of kick it up a notch and try these questions where you're not gonna get nice whole number answers, which is kind of the point of doing completing the square. Remember what I said at the beginning, right? Because you would only use completing the square unless either A, the regions ask you for it, and 2 is you cannot factor it like how we did it right here, right? The old-fashioned way, right? So knowing that, let's try it completing the square with some crazy numbers, okay? So again, I'll do this example with you guys, all right? Now here, again, now just by looking, I already know that what's up, because 59 is a prime number and there's no way 59 and 1 can somehow give you 6, right, when you add them. So that's not gonna work. So what do we do then, right? Well, we're gonna add 59 on both sides, all right? The steps don't change. The answers look kind of wacky because they got radicals and decimals and whatnot, but doesn't really change anything. Okay, so these cancels out, and I got 59, right? Now, again, the question now becomes, I really don't like using v as a variable. It looks like a check mark. All right, is this, right? V squared plus 6v plus what will give you that perfect square trinomial on the left side? So, okay, let's draw a little box on the left side, figure that out. 6 is the middle value, right? The middle coefficient. 6 divided by 2, that's 3. Oh, it's actually the same thing. Yeah, it's the same thing as the first one. It's all right, 9, right? So plus 9 on the left, plus 9 on the right. All right, so let's see what that looks like. So v squared plus 6v plus 9 equals to what, 68? Yeah, okay. Now, here, I know what this is already, right? It's a perfect square. By the way, how many times can I say perfect square trinomial in this one video? All right, so let's see. So that's 3 and 3, right? That equals 68. I can rewrite that, right? V plus 3 squared equals to 68. Take the square root from both sides, right? Now, this is what I'm talking about when I say, you know, something like this is a little bit more complicated because 68 is not a perfect square, right? So now, let's take care of this first. So here we got v plus 3, right? Because that's what taking a square root does, right? It gets rid of the second power. And here we got 68. So I'm going to take this to the side again, and I'm going to work out the square root of 68. I'm going to break it down to simplest form, all right? So I need to think of two numbers that multiply to 68 where one of them is a perfect square, all right? So what would that be? Let me think about it for a second. All right, took me all of 1 second to think about it because it's easy. You just start going through all the perfect squares, starting with 4, right? Because, you know, 4 is a perfect square. It turns out it's 4 times 17, all right? Let's see, let me just double check. Yeah, all right, so that means this is 4 squared, that's 2. Square root of 4, not 4 squared, square root of 4, right? 2 radical 17. So far, so good. Now, it's not just 2 radical 17, it's actually positive and negative. 2 radical 17. Now, I know I haven't spent a lot of time on turning this into this. Okay, we only spent a little bit of time at the beginning of the year. I understand that. So I'm also running out of time here. Now, here, to solve this part is actually a little bit easier. Because here you can just subtract 3 like that, right? That cancels out. Now, some of you might say, Mr. Ng, what am I supposed to do here? I got all these things going on. I got plus minus, I got 2, I got radical, and I got, on top of that, I got to subtract 3, right? It's not that hard. Just write the minus 3 here, plus minus, like that, 2 radical 17 like that. And if you want to write it out, you can do this, by the way. You can do negative 3 plus 2 square root of 17 and negative 3 minus 2 square root of 17, just like that. Okay, it's perfectly okay to do that. all right? Because sometimes they'll write the answers that way, sometimes they'll write the answers this way, okay? So now, if you feel up for it, give this question a good old try, all right? When you come back, I will go over with you, okay? So press pause right now. All right, and we're back, okay? So to make sure everyone can see everything, I'll use a different color, all right? So for this question, right, again, step one, all right, I need to move the 7 on this side because, again, 7's a prime number, and you know that 7 times 1, right? Those are the only factors, and there's no way 7 and 1 can make 4, right? So you see why using completing the square has its value, all right? It's not, it's not done, for no reason. Now, move that over there, so that means I got x squared plus 4x equals 7, right? I'm just adding 7 on both sides, right? Now, step 2 is now I gotta figure out, hey, what number can I put here, right? What constant can I put here so that this whole expression on the left side is yep, you got it, perfect square trinomial, right? So let's take that onto draw a little box to the side. The middle term is 4 divided by 2. I already know what it is. It's 2 squared. So that's 4. So I'm going to add 4 on both sides. All right? Because I got to be fair, right? What I do on the left, I got to do on the right. Now, here, I can rewrite this already. Because this is x and x, right? And this is 11. This is x plus 2 times x plus 2, right? So here, step 4, I'm going to rewrite it as using an exponent equals 11. So far, so good, right? So the 5th step, I'm going to take a square root here on the 4th step. And the last step is almost done, right? So here we got square root of 11, which is positive and negative square root of 11. Now, I did this on purpose too. So I made myself do this one with you guys because I just want to review how to turn this into this. Whereas for this one, there's nothing to simplify, all right? And I think that's the right approach to take to let you guys try that without adding any more complications. Now, here, I'm going to solve it, subtract 2 on both sides, all right? Now, just so you know, as a review, no one really writes this, all right? I'm just going to tell, no one writes it like this, all right? Okay? So, almost everyone writes it like this, where the negative 2 is in the front, okay? So it will be negative 2, and then just plus minus square root of 11, like that. And if you want to, you can write like this, even with a bracket, even more sophisticated. You could write negative 2 plus square root of 11, and negative 2 minus the square root of 11, all right? That's the super duper sophisticated way of doing it, all right? You will impress a lot of people if you can write like this, all right? Now, lastly, why do we do this? When we use this method, the variable x only appears once, all right? What I mean by that, you see how here the v appears twice, but if we write it as a exponent, the v only appears once, okay? I just don't even know how that's like a great advantage, all right? This is still better than using the quadratic formula, still better than using a sledgehammer, all right? And also on the regions, they just tell you that they want you to solve it like this, and they'll like make sure you do that, okay? And actually also the multiple choice questions specifically ask you for that, okay? Now, it's a very long video. Oh no, wow, okay, all right. So I'm gonna sign off here. Tomorrow and the day after, we're gonna practice quite a lot, and that's it, okay? All right, thanks for watching, thanks for hanging there, thanks for being so patient. All right, signing off here, and take care, bye-bye. OMG, that was so good.